All right, so relations and functions, here we go, video 1 of chapter 2. So a function is a relation where every element of the domain is paired with exactly one element of the range. Okay, so meaning no x values are going to repeat, so we could write that in there. No x values repeat. All right, so we have a couple different kinds of functions. So if we have a function, okay, we can call it one-to-one, or we could call it onto, okay? So sometimes it's one of them, sometimes it's both of them, sometimes it's neither of them, okay? So one-to-one, each domain value is going to have a different or unique range value, okay? So each x value, because remember domain is x, so each x value has a different y value. All right, onto means that each element in the range has been paired with an element in the domain. So every y value has an x value associated with it, is an easier way to remember that. Okay, so we're going to look at a couple examples here. So tell whether each relation is a function. Then we're going to determine the domain and range. And then if it's a function, we're going to tell whether it's onto, one-to-one, both, or neither. So we cannot do this blue section here, this last piece, unless it is actually a function. If it's not a function, we cannot do that last piece. Okay, so tell whether it's a function. Okay, so do I have any repeating x values? I've got 2, 4, 6, and 7. No repeating x values. So yes, it is a function. All right, determine the domain and range. Well, domain is your x values, range is your y values. And in this case, it's pretty easy to see which is which. So my domain is 2, 4, 6, and 7. My range would be 3, 4, 6, and -1. I never want to repeat anything in my domain or range. So let's say I would have had 2 3s down here in my range. I would have only listed it once down here in my brackets. Okay, and then tell whether it is onto, one-to-one, both, or neither. Okay, again, we're doing this because it is a function, okay? If it wasn't a function, we would have skipped this part. All right, so does every x value have a different y value? So 2 only has the 3, okay? Nothing else has a 3, okay? Nothing else has a 4, nothing else has a 6, nothing else has a 7, or a -1, sorry. So every x value has a unique or different y value, okay? So that makes it one-to-one, all right? Onto means that every y value has an x value associated with it. Okay, so 3 with -2, 4 with 4, and so on and so forth. So that means it is onto as well. So this is both onto and one-to-one. All right, let's look at another example here. Okay, here we have some dots on a graph. Okay, before we can actually do a whole lot with this one, we're going to list our domain and we're going to list our range first. Okay, so our domain is our x value. So if we look at these points, the easiest way to do this is go list the coordinates. So this is -1, -1. This is 1, -3. This one is 1, 0. This is 2, 2. Yeah, we'll say 2, 2. This is 1, 2, 4, 0. Okay, so my domain value is my x value. So I've got -1, 1. I've got another 1 here, but I'm not going to put it. A 2 and a 4. All right, my range then is my y value. So -1, -3, 0, 2, and another 0, but I'm not going to list it again. Is this a function? Well, no, it's not a function because x repeats. Right here we have an x of 1 and another x of 1, so it repeated, so it is not a function. So that means I don't need to tell whether it is onto, one-to-one. All right, my next one here, this is what we call a mapping diagram. You guys have probably seen these in Algebra 1. Okay, a mapping diagram, it's just saying that 2 goes to 0, so it's like I have the point 2 comma 0, I have the point 3 comma 1, I have the point 5 comma 8. Okay, so in this case, do I have any repeating x values? Nope, so yes, this is a function. Okay, my domain then. My domain and range are easy with mapping diagrams. You just list the domain as the left bubble, 2, 3, 5. Your range is the right bubble, 0, 1, 2, and 8. Okay, so because it's a function, we can say whether it is onto, 1-to-1, both, or neither. And in this case, every x value has a different y value. Okay, 5 doesn't go, or 3 doesn't go to 8 as well. Okay, nothing overlaps. So all these guys only have one arrow going to them. So we know that it is onto. Or sorry, we know that it is 1-to-1. Because every x value only has one y value with it. Okay, but this y value here is missing an x value. There's nothing with that one, so it is not onto. Okay, so it is only 1-to-1. All right, let's look at this guy here. So again, we could list our domain and our range. Our domain would be -1, 2, and 3. Our range would be 0 and 2. Okay, is it a function? Well, yes, it's a function because we only have one x value, or our x values are not repeating. So we'd have like -1, 0, we'd have 2, 2, and we'd have 3, 2. So our x values didn't repeat at all. So yes, it's a function. Okay, is it 1-to-1, onto, or both, or neither? Okay, well in this case, every x value has a y value, but if you notice, these two x values go to the same y value. Okay, so that makes it not 1-to-1. Okay, but does every y value have an x value associated with it? Yes, so that means it is onto. So it is only onto. Because, again, these two x values share a y value, so therefore it is not 1-to-1 because they don't have different y values. All right. Okay, last one like this. So let's list our domain and our range. We can list our set of points if we want first. So 2, 6, 8, 7, and 4, 7. So do any x values repeat? No, they do not. So yes, it is a function. A quick way to tell that is if there's two lines coming off of one of the x values. So if the 2 would have also went to the 5, that would have automatically told us that it's not a function. Okay, so our domain then is everything in this bubble. So 2, 8, and 4. And our range would be the 5, 6, 7, 9. All right, does every x value have a different y value? Well, if we look here, 8 and 4 both go to the same y value, so it is not 1-to-1. Okay, but does every y value have an x value? Well, 5 and 9 are just kind of floating out in outer space, so it is also not onto. So this is neither. So even though it is a function, it is neither onto or 1-to-1. All right, so discrete function or a relation. Discrete function or relation, or we have continuous function or relation. Okay, so basically a discrete function is one where we're just plotting a bunch of points. Okay, a continuous function is one that actually has a line or where all your points are connected. Okay, so if you have a graph and you're given something that looks like this, that would be discrete. If you're given something that looks like this, that is continuous. Okay, we have something called the vertical line test. This is another quick way to determine whether something's a function. Okay, basically if you take a vertical line, which is this way, okay, vertical up and down, and you draw it through your graph at any point and it crosses more than one point on your graph, it is not a function. So if I look at this line right here, okay, imagine my pen here is a vertical line. It's only going to cross this graph in one point everywhere I go, which means that would actually be a function. Okay, vertical line test examples. Okay, so let's say I have these couple graphs here. Okay, well here, this thing is called a parabola, okay? If I draw a vertical line anywhere through this graph, it's only going to ever hit one dot on my graph. Okay, those aren't perfect vertical lines, but that's what would happen everywhere that we go. Okay, so this is a function. The vertical line test only hits one spot on the graph. Where if we go over here and look at this curvy graph here, this S, if I draw a vertical line here, it hits 1, 2, 3 dots in the same graph or on the same line. So this is not a function. Hits 3 dots or 3 spaces on graph. Vertical line test does. Okay, basically the reason why that works is because these all would have the same x value. Okay, and remember, if things have the same x value, it's not a function. Or if x values repeat, sorry, it's not a function. Basically, one big thing to remember is that every linear function is every linear relation is a function. That's kind of going back to this continuous function right here. This would be a linear graph right here, straight line, so that would always be a function. Okay, otherwise here's another picture of that too. Okay, here is, we're gonna graph this line here, y equals 2x plus 3. We're gonna determine the domain and range, and then we're gonna determine whether it's a function, is it one-to-one, onto, both, or neither, and is it discrete or continuous. So graphing this is a quick little refresher for you. Our slope would be 2 or 2 over 1. Okay, remember our slope is the number before the x. Your b or your y-intercept is 3. That means we go up to 3 on our graph, put a dot, and then from there we're going to go up 2 and right 1 because our slope says go up and right. And here's my graph right here. Okay, so we graph that. Okay, determine the domain and range. Well, anytime you have a line, it's all real numbers. Okay, that is a fancy way of saying all real numbers. Okay, so all real numbers. Is it one-to-one, onto, both, or neither? Okay, this is going to be both. And is it discrete or continuous? This is continuous. All right, and then our last examples here. Okay, sorry, this video is getting a little long, guys, but we're gonna wrap it up here in a second. Okay, so these ones, we're plugging these values in. So f of x is just a fancy way of saying y. Okay, this is saying plug this in for your x value and see what you get out. So really what we're doing here is saying 2 times 2 squared minus 8. Okay, so 2 times 4 minus 8, so 8 minus 8, which is 0. Here we're going to plug in negative 4, so 2 times negative 4 squared minus 8, which gives me 2 times 16 minus 8, which gives me 32 minus 8, which is 24. And then here we're going to plug in 3y. So we can plug in letters as well. So we'd have 3y to the second power minus 8. So we're replacing the x with the 3y. Okay, well that gives me 2 times 3 squared is 9, y squared minus 8. That would give me then 18y squared minus 8, and there's nothing else I can do with that. So that would be as simple as that can go. All right, and that was your video 1, relations and functions. We will see you next time, guys.